Okay, you said that was in 2.2?
Yes.
So if we go to 2.2 in our book, and we look at just how to answer the writing exercises, the 1 through 10.
No, 107.
Oh, 107.
Yeah.
I thought you said 1 through 7. Sorry, 107.
107.
So this is an example of something that you need to kind of create, or it's asking you if it's possible to create. Can you find two sets whose union and intersection are the same set?
That's where I got confused.
Yeah. So it's asking you to make up a set where their union and their intersection is the same. So does anyone have any ideas?
I put down, and I don't know if it's right or not,
Okay.
but I put down A equals a set of people who drive automobiles. B equals a set of people who drive cars.
Okay, so that wouldn't necessarily be the union and the intersection and the same set, because some people might, an automobile is a pickup, right? So there's, if you said, okay, these are all the people that drive automobiles, these are all the people that drive cars, it would be true. Oh wait, sorry, let me think about this. This is totally encompassed in here, right?
Right.
So the union is A.
Right.
The intersection is B.
Right.
But we want to be the union and intersection be the same set. Right? So A union B in this case is A, and A intersection B in this case is B. Because there are some things outside of people that drive cars, the people that drive pickup trucks, they're going to be not in B, but they'll be in A. That's a good along the line, and that could possibly come up when B is a subset of A. The union is the bigger set, and the intersection is the smaller set.
So how could I change that to?
So basically, we want to get rid of anything outside of B.
Right.
So if we kind of want to come up with sets that are the same, right? So if I said A was the set A, B, C, and B was the set B, A, C, these are the same sets. This is one of the easiest ways to do this, right? So if I draw a Venn diagram, this is A and this is B, A, B, C, I should use a smaller case A here, A, B, C is all going to be in the union. So the intersection, right? So the intersection is ABC. The union is still ABC. So in the case where we're looking at the sets that are equal, can you find two sets whose union and intersection are the same set? When A equals B, the union, so just
Like
think of
1, 2, 3, and 3, 2, 1.
Yeah. So anytime A equals B. So when A equals B, A union B is A, and A intersection B is A, or B. You could write it or B, but it's the same, it represents the same set. Basically, when they're the exact same set, their union and the intersection are the same. But that's just, part of the critical thinking of it. Sometimes you want to make it more difficult than it ends up being, but this is a good approach because we come up with something else. We have the union when B is a subset of A, a proper subset of A, then the union of A and B is A and the intersection is B, which is just kind of beneficial sometimes when we can think of the union and intersections of things. Any other questions on the homework? Yep.
2.3.
2.3, number 13. So we are looking to draw a Venn diagram to shade in the regions. We're looking at 13. Go ahead and here. So the first step on this is to draw a Venn diagram with 3 regions, A, B, and C. So we might say, okay, A, we're going to shade in A. So everything that's in A gets shaded. Then we're going to shade in B intersection with C. So where does B and C intersect? Right here. And then I'm combining them with a union. So my final answer is going to be anything that's shaded, right? If it was A intersection B intersection C, then the answer would only be this green area. But it's not. It's a union, so the answer is anything that's shaded. So typically this is 1, 2, 3, 4, 5, 6, 7, and 8. And of those 8 regions, my answer would be 1, 2, 4, 5, and 6. And these answers should be in the back of the book, right? If you go to the back, you should get a Venn diagram that's shaded this way. So you should be able to check yourself. And if anything's not clear in the back of the book why that's that way, bring it to class and we can talk about it. And we can discuss how that ends up that way. Does that make sense? A lot of it's just exposure too. When you do these problems multiple times, you can kind of say, you know, if it was an intersection, I might not have shaded all of A because I know it's only going to be the things that intersect with it. So I might just kind of put my finger there and say, okay, I want to say anything that intersects with B intersects with C, and then that's only going to be this green region.
I guess what confuses me is when it's like, I don't even know what you call it, when the U is facing up and then like when it's turned down.
That is really the only thing you're kind of evaluating. Is it a union or is it an intersection? This means it's a union. So if I just draw this A union B, graphically what that means, if I have 2 sets, A union B is going to be shading in everything that's in A, everything that's in B, or everything that's in both A and B. A intersection B is when the little U is pointing down. A and B, and that is going to be the shaded region of the only 2 the things that they overlap.
What they have in common.
What they have in common. It's the and, in a sense, it's written as or. There. The inclusive or has to be in both. Question.
On 2.2,
Okay.
number 31, I was confused with that one.
2.2, number 31.
Yeah. Because I thought the E, doesn't that stand for element?
Yes. So here it's asking, I'm guessing true or false?
Yes.
Yes. So the difference is this is saying the set E is an element of this set, which doesn't make sense because this is a set of numbers and this is a set. A set can't be an element of a set of numbers. It's on notation. It's if this was 3 is an element of 1, 3, 5, 7, then this would be yes, this is true.
Okay, but it's just because it's saying a set, the set 3.
Correct.
Okay.
Saying that set 3. So you have to be really careful with brackets, things like that. So it's a little tricky, but once you get more exposure to it, you're like, okay, this is saying a set. And it's going to get more important when we write sets, that we write them as sets instead of 1, 2, 3, 4. If you just write that out, if you write 1, 2, 3, 4, that doesn't tell me anything. This tells me it's a set of numbers that include 1, 2, 3, and 4. A lot of times we'll give it a name. We call this A. Question.
On number 95 in section 2.
Okay. 95. 95.
The college freshman.
Yes. Let me, oops. Okay, college freshman can choose one, some, or all the following classes for semester: an English class, a math class, and a foreign language class. science class, philosophy class, and physical education. I'm going to run out of colors here. Philosophy, physical education, and a history class. How many different possible does she have for her new schedule? So does it say how many she's picking?
Yeah, but I was confused, like, do you count, like, because when I did it out, like,
Mhm.
it counts like the empty set as one as well. So would you count an empty set, which, because she has a possibility of not taking any classes, but like.
So she says can choose one, some, or all the following classes. So since it says, yeah, I wouldn't include the empty set, no. So the proper set would be counted
Okay.
because she could take all of them, right? Because it's,
Proper set one, but the empty set.
yeah, so it's still going to be 2n minus 1.
Okay.
Yeah, this is a counting type of problem. Combinatorics is what they call it in math. It's fancy way of how many different combinations can I come up with. And that's exactly what it is. It's a subset.
Okay.
How many subsets are there possible? So that's one application of the subset counting principle.
I just wanted to double check on that.
Yeah, sometimes the wording gets a little tricky. In today's lecture, we're going to come up with things like at most 2 classes or at least 1 class. So you have to really be careful what that means. Does that mean 1? Does that mean 0, 1, or 2? Or does that mean 2 or 3? So we're going to talk about those words that come up that you have to be really careful with.
Thank you.
Any other questions on the homework? So today's lecture kind of is just an application of what we talked about. So using sets to solve problems. All we're going to do today is solve problems using the Venn diagram. And we're going to look at 2 different types of Venn diagrams when we have an intersection of 2 units or 2 sets. And then also we're going to look at an example where we have an intersection of 3. We talked about this last time, and this was on your handout last time, use Venn diagrams. So anytime it says solve a problem using a Venn diagram, you want to draw this kind of region. And I might even give this to you on the test just so it makes my life a little easier when I go to grade it. I can see things a little clearer. So this is the first example we're going to do. 2008, there are 36 states that had some form of casino gambling in the state. 42 states sold lottery tickets of some kind. 34 states had both casinos and lottery tickets. Draw a Venn diagram to represent the survey result and find out how many states have only casino gambling, how many of them have only lotteries, and how many of them have neither, right? So we know 36 of them have some form of gambling. So we can come up with how many have no form of gambling. Pretty easy, right? Probably don't need a Venn diagram for that. But we know there's only 2 sets here, right? We have lottery tickets and casino gambling. 36 of them, right? So I'm going to put little boxes in here. 1 box, 2 box, 3 box, 4. 1, 2, 3, 4. So what this tells me is 1 plus 2 plus 3 has to equal 34, right? 34 of them going back to, or 36, sorry. 36, not 34. Right, that tells me 36 states had some form of casino gambling in the state. So going back here, this 2 and 3 is going to, the total in 2 and 3 is 36, right? Because this region represents only casino gambling. This region represents casino gambling and lottery tickets. This one is only lottery tickets, and then this region is neither. So, do you guys see the different regions there? 1, 2, 3, and 4. So 36, that tells me the total of this circle is 36. But I don't know how much goes here or here yet. Going back to the statement, 42 of them sold lottery tickets of some kind. So this is going to be 42. So I know the total of that circle is 42. So you have to read the statement and interpret where the number goes within your Venn diagram. 34 states had both casino gambling and lottery, right? So 34. 34 goes there. That's where they overlap, the intersection. So now that I know 34 has both lottery and casino, how many of them are just casino? 2, right? And if I know 42 just sell lottery tickets, and 34 sell lottery tickets and casinos, how many just sell lottery tickets? What? 8? Right? So the last thing that we can deduce from this is how many of them do neither. So if I know there's 50 states, right? Back in 2008, there are 50 states. So I have to know that this number plus this number plus this number plus the number out here has to add up to 50. I can take 42 minus 30, or 42 plus 36 minus 34, and that will tell me what these three numbers are if I've done that correctly. There's kind of a couple of different ways to approach it, right? Because we talked about this was A and B. The number of elements in A and B is the number of elements in A plus the number of elements in B minus the number of elements in the intersection. We talked about that last time a little bit. But if I know how many elements are in this area, this area, and this area, I can just add those three together. So what do we get?
6.
6 outside. So this Venn diagram gives me the ability to answer the questions now. So going through the process, we have 34, and they switched the picture here, but that's okay. They have lottery tickets on the left hand or the right hand side, casinos on the right. We got the same numbers. So now answering the question, there are only 2 states that have casino gambling but no lottery tickets. That would be represented here. Right? There are 8 states that have lotteries but no casino gambling, and there are just 6 states that have neither. You guys see that? So after you do your Venn diagram, you actually have to then apply it to the questions. Know that this region means only lottery or only casinos. This region is only lottery tickets. This region's both. This region's neither.
You want us to write it out like that?
Usually it'll just be like a statement. You can just write 5 if that's the answer. So no, you don't have to write it in a full sentence. You can just write it as a number. On this exam, a lot of times I'll put a Venn diagram 1 and a Venn diagram and then questions. And so you'll get a point for every region in the Venn diagram that's correct. And then you also get a point for evaluating the questions correctly. Because I had students that can do Venn diagrams, but they don't know how to interpret them. If I say, how many of them sold only lottery tickets. Well, some students will add these 2 numbers together instead of just saying 8, only lottery tickets. And we'll get into a little bit more complicated examples where you can do the Venn diagram relatively easy, but applying the question, like how many students took at most 2 classes? So you got to see any different areas that overlap. And we'll do an example of that in the homework. All right, so I want you guys to do this one. Just take, 5 minutes. This is this example 2 on your, so I want you guys to do this, and then we'll do it together in class and kind of compare. This is kind of the same setup. It's only a 2 set diagrams, 2 set Venn diagram.
One more thing.
Well, just how many of them have neither?
Have neither. Oh, I have 500.
Yes. So the 120 here tells you the total of these two. Is 120, total of these two, 72. And then these four regions here add up to 500. It's kind of like a Sudoku puzzle almost, you know, you kind of have to go in, yeah. Yeah, so you know that the total of these two are 72. Everything in this is 172. But you know that PM one still are gonna be 172. Yeah, I'm thinking there are 40 and 41. So if you add this three numbers here, make 500 minus those numbers. Yes, yes. I think you guys are in a different page.
I get it right.
That's good. I don't know the exact numbers, but that was pretty good.
I know, I'm loving it.
So what do you guys get for only tattoos? 79. Anyone else get anything else? What about body piercings? Only body piercings? 31 and neither? Did everyone else get that? So the Venn diagram, we go through, put the numbers in there. The book doesn't show where the 79 or the 31 comes from. I like to put the 120 up there, and I want to be careful that I don't include that, but that's going to tell me when I go to add up these numbers, 79 plus 41 plus 31 tells me how many people have we have accounted for, and then 500 minus that is how many we're missing. So that's the neither there.
So you add the middle section even though it's already counted?
There's two ways you can do it. We know what was 79, what was this? 72? You could take 120 plus 72 minus 41. That's going to be the exact same thing as taking 79 plus 41 plus 31.
Oh, okay.
Because this
Gotcha.
kind of, it's like, the 41 is counted twice, right? 79 plus 41 is part of the 120.
Okay,
The
that makes
41
sense.
plus the 31 is part of the 72. So if you add those two numbers together, you have to take out the middle, but it's going to be the same as adding those three regions.
Because I added all three and then I was like, wait, that 41 was counted for both? So then I figured out.
It's not, because
But since
it's a
the
separate
whole
region.
circle,
Yeah,
then the
if you
whole
would have
circle-
done 120 plus 72, then you would have had to take out the 41, because that's counted both times. But if you do 79 plus 41 plus 31, you're only counting the or the intersection people once.
Okay.
Where if you're doing 120 plus 72, you're counting those intersection people twice, so you have to subtract them. So this next example, we have to get a little bit careful, and we'll do the example. I'll hopefully have time to pull up the one in your homework, where it asks a very similar type question, but it asks like at most 2 classes. How many people are taking at most 2 classes? What does it mean to say at most 2 or at least 2 classes? Yeah, so we have to be a little bit careful on the wording and then be able to translate that to the Venn diagram. This one's pretty straightforward. We have 300 first-year students at a large Midwestern university. We have math, English, and speech. So we need a Venn diagram with 3 circles that overlap. And almost on this, it's almost a little bit easier to work backwards with the numbers. 45 are taking all 3. 91 are taking both math and speech. So you look where math and speech overlap. And you know, if 91 of them are taking both math and speech, 45 of those are also taking English. So if you take 91 minus 45, that tells you how many are only taking math and speech, and not math, speech, and English, right?
Do you do that with every single one?
Yes. So if you work backwards here, math, speech, and English, a lot of times all 3 will be given as 45. Okay. All 3 is given as 45. We know 91 of them were taking math and speech. Math and speech. This area has to add up to 91, right? Because these are the people that are taking math and speech. We know 45 of them represent here. So 91 minus 45, what would that be?
21 minus
40.
46.
6? Yeah. So you see how this 91 tells me 91 are in this region, but this region is in 2 parts. And I already know 45 of them overlap here. So I do the same thing and I just kind of work my way outwards. And no, go ahead. Question?
Okay, so when you get to the math portion and then you solve the math and English, do you subtract both the math and speech and math and English?
When you get to the math, you subtract the 3 regions that are overlapped. Same concept, is just a little higher level here, right? And a lot of the times, reading through this, if you just work backwards, it comes out pretty easy. 111 are taking both English and speech. So English and speech, 111 of them, but out of the 111, 45 of them are taking English, speech, and math. So we have how many of them are just,
66.
what do we think?
66.
66?
How'd you get the number?
So I was given 111 are taking English and speech. And English and speech incorporates this area here. I know 45 of them are taking English, speech, and math. So out of the ones that are taking English and speech, 45 of them are also in math, so they're in this region. So I take 111 minus 45, 66. Right? Math and English, we get 142. So I know the sum of these 2 regions is 142. So math and English, so 45 of them are taking math, English, and speech. If I know 140 of them, 142 are in math and English, take 142 minus 45 and get 97. You always kind of start in the middle and kind of work your way out. So we got that. 170 were taking speech. 170 were taking speech. So everything in S has to add up to 170. $194 and 210. A lot of times I will come in here and just kind of circle these. So in the end, I don't get confused where they're at. I know that those are just the circle. The circle that represents these 2 is 142. The circle that represents these 2, 111, these 2, 21. This big circle is 194, big circle 170, circle 210. So what did we get here for math? I take 194 minus 46 minus 45 minus 97. Or I could take 194 minus 91 minus 79 because I know these 2 add up to 91. Generally, it's safer taking 194 minus the 3 regions if you've done your math correctly, right? So what do we get there?
6.
Do we get 6? What do we get for just speech?
13.
And what about just English? 2. So now we know 300 students are polled. So if I take 300 minus 1, this region, this region, this region, basically my 7 different regions, I get my 8th region. What do we get? 25. And there's a little bit of a shorthand. You know the sum of this circle is 194, right? But you have to be careful because you don't want to count them more than once, more than twice, or more than 3 times, right? So you want to be careful. You could say, okay, this is 194, so I could take 300 minus 194 minus 13 minus 66 minus 2 and still get 25. Generally, it's safer just to take 300 minus this region, this region, this region, and so forth, and just be careful the way you plug it in your calculator.
So to find the 8th region, we take the total, which is the 300 minus everything?
Yes. So basically what the 300 says, that every region has to add up. Basically, this is just another big circle. Every region in this circle has to add up to 300.
So on C, when it says math or English,
Mm-hmm.
does that not include the 46 and, well, I'm sorry, the 97 in between?
So math or English would be this shaded region here that includes any that are in math or English. So you kind of think of the union. So you add up 1, 2, 3, 4, 5, 6, the 6 different numbers there.
Okay.
Or an easier way to do it is to take 25 plus 13, or take 300 minus the 300 minus 13 minus 25, and that will tell you how many is added up here.
Okay, so 300.
There's 2 ways to approach it. Math or English, or both, right, would be this, and this. This student is in English, so they count. This student's in math, they count. It doesn't matter, they're in speech as well.
It's just a math class, right?
Yes. Yes. So how many do we have in only English? 2, right? Answer that. Go ahead and go. Working backwards, their M, E, and S are a little different than ours, but that's okay. We're going to end up with the same answers. And if yours look different, that's fine. If you have English here, math here, and speech here, that's fine, as long as the numbers come out correctly. So we have, there are only 2 students are taking only English. Math and speech, but not English, right? So we would think math and speech, but not English. That would be the region that's 46 students. Right? Math and speech, so it's where they're overlapping, but not English. So we take out this region, so our answer is 46 there. We want to know math or English. There's a couple ways we could go about it. We could add this region, this region, this region, this region, this region, and this region, or we can take 300 minus 25 minus 2. And I know everything has to add up to 300. And I'm only talking about all the other regions except these 2, so it's a little bit of a shortcut there. But if you do it the other way, you should get the same answer. If you add 6 plus 97 plus 45 plus 46 plus 66 plus 13, that's the exact same of taking 300 minus 25 minus 2. You guys see that? And do you guys see how kind of the shading comes along here? Where I say math or English is kind of like M union S. So if I can add up those regions, I get the answer there. Any questions?
And then the and would be like in the intersection.
Yes, if it says math and English, which is, here, math and speech. If it was math and speech, it would be these 2. And then if it says math and speech but not English, it would just be this region here.
Okay.
So you just got to get a little bit comfortable with the different ways they can ask you a question. One comes up on the homework that says, how many students are taking at least 2 classes? At least 2 classes. That's going to be these 4 regions here, right? 2 or more classes. At least 2 means they're taking 2 or 3. if it said how many students are taking at most 2 classes, it would be this region, or at most 2 classes, it's everything but the middle. Okay.
Can you say B again for me?
B,
Math and speech.
but not English.
Yeah. No.
So this would be math and speech, right?
Now wait a minute. Now what if it?
But
Would it be include English?
yes, that's what I'm saying. I'm saying that this is math and speech together, right? This is math and speech, but it says math and speech, but not English. So we would only include this region here. This is math and speech, but doesn't include English.
Now what if it just said math and speech?
Then it would be these 2 regions together,
But that still includes English.
but it doesn't care. If it says how many students are taking math and speech, some students are taking math and speech in English, but that doesn't matter. We want to know how many of them are taking math and speech.
That was my only question.
Yeah, so it just gets a little, you know, on the notation in the words, it says only math and speech, then it would just be this region here. So how many are teaching math and speech? It would be these 2 regions here. And that was given in the problem, and that's why they didn't ask it.
I'm solid now.
All right. Math and speech was 91, and that was given in the problem. So they wanted to jump up a level and ask you math and speech, but not English. All right, so I'm going to pull up your homework card for this section. Pretty straightforward what we did in class. A couple of them are a little different, actually, what they give you. Because typically they gave you the intersection, and then they gave you how many was in A and how many was in B, and you had to deduce how many was only in A and how many was only in B. Your homework is 1, 5. 5's a little different. 5 tells you how many students answered the first bonus question, and how many answered the second bonus question, and how many didn't answer either. So it doesn't give you the intersection, it gives you how many of them didn't answer. So you have to find the intersection. So let's go through this one, number 5. This is part of your homework. Do it on this so it's recorded. Ignore this. So you know 20 students were taking a midterm in psychology. We'll call this the first bonus question, the second bonus question. 15 answered the first bonus question, so I know the sum of these 2 circles is 15. The sum of the second bonus time is 13, and then I know 2 didn't bother to answer either one. The percentage is just one extra step where you take the number of students that tried both questions divided by 20. So we have to know the number of students that tried both questions. So we have to be a little bit careful with our overlap, right? We have to be careful on how we calculate our overlap, right? Because we don't know what our overlap is, how many of them answered both. So we can set up almost an algebra type problem to solve for x. So what would we know we need to be able to do? And there's a couple different ways you can do it. Basically, this is, let's call this if x is the intersection, what would be outside of 1b, one of the bonus? Very good, 15 minus x. What would be over here? 13 minus x. So now if I add 1, 2, 3, 4, if I add these 4 regions together, what is that going to equal? 20, so then I have to solve for x. right? So 15 minus x plus 13 minus x plus 2 equals 20. Fifteen plus 13 minus x, that's the exact same thing as saying 15 plus 13 minus the intersection, because we're counting x twice when I add 15 plus 13 because x of them overlap. Does that make sense? So this is 30 minus x equals 20. So what does x equal? 10. Do you see how that's a little different? You don't know how many of them overlap, so you have to be able to find that way. So 10 of them overlap. So then filling this in, this becomes 5, this becomes 10, this becomes 3. What percentage of the students tried both questions? 50%, right? 10 over 20 is 50. Times 100 is 50%. Or 0.5, but it wants a percent, so. What percentage tried at least one question? 18 over 20? Times 100. So that would be 90%.
Wouldn't it be 15 over 20?
Well,
Because
two,
that's like the first bonus question.
yeah, it says at least. Again,
Oh, at least one, okay.
yeah, that at least and at most will kind of come up, and you have to be
said
really
just one
careful.
question.
Yeah,
Okay.
if it, yeah, not question one. It's at least one question, yeah, because there's
Gotcha.
one bonus and then the second bonus. So yeah, 15 over 20 would be the percentage of students that answered the first bonus.
Right.
13 over 20 would be the percentage of students that answered the second bonus. Right. So sometimes we can, with statistics, we can be really tricky the way we word things. 50% answered both, 90% answered at least one. Here's an example. I'm not for sure if you do number 7 or not. But here's an example. If you work backwards, it makes it a little easier, right? Scholarships, loans, and grants, 2 is in the middle. So scholarships and grants tells you 5 of them are just scholarships and grants because 2 of them are scholarships, grants, and loans. And then working the way up, it makes it a lot easier to go through. This one's pretty straightforward. How many students got only scholarships? Got loans and private grants, but not scholarships. Math and English, but not speech, or along those same lines. You guys do number 9. Yeah, so be careful when it says exactly 2 of the 3 regions, right? Exactly 2 would be these 3 regions. 3 things overlap. Exactly 2 would be this one, and this one. This one would be more than 2, and this would be less than 2. So if it says exactly 2, you need to find the regions that only 2 things overlap. B, pretty straightforward. You need to find that region. Exactly 1. Exactly 1 of the reasons. That's going to be this plus this plus this. How many of them are taking exactly 1 class? 6 plus 13 plus 2.
So that Venn diagram's gonna be like that.
Yeah, it's going to look just like this, except for math, English, and speech. You're going to have poor attendance, not studying, and not turning in assignments. But the form stays the same. Yeah. B and C, pretty straightforward. You got to find that specific region in the Venn diagram. A and C get a little trickier because you got to say, what does it mean to be exactly 2? What does it mean to have exactly one of the 3 regions? And then if it comes up with at most 2 at most 2 excuses, you got to be a little careful with that. I don't think it comes up in the homework. You guys, I think you also do 15. How many more listen to AM than FM? That's just interpreting the results in your Venn diagram. How many listen to some form of radio but not AM? Yeah, satellite radio, FM, or AM. So being able to answer the question, how many more listen to AM radio than FM radio? You have to be a little careful because it's not just AM, it's AM in general that listen to FM in general. So a lot of this is just exposure, going home, working through it. Again, the answer's in the back of the book, so you can pull that up. If something's not clicking in class, then we can go over and see exactly how you're interpreting it. We're going to do a little bit more examples of this tomorrow, so I might kind of have a handout, like a worksheet, almost kind of like a pre-exam type thing for you guys to work in class. And then we'll continue on with our last section, 2.5 on Friday. Review on Monday, and your test will be on Wednesday. So I'll collect your homework on Monday. All right, I'll see you guys Wednesday.
That's helpful.